in centimeters for 40 local high school students. Jeez Louise. Okay, we have to create a histogram for the data with bin widths of 4. Okay. I think you guys might have made a histogram before, but we are going to make sure that everybody knows how to do it, okay? So, we want bin widths of 4. Oh my gosh, my brain is just like struggling today. So make yourself some beautiful columns. It's kind of like a T-chart, only you've got 3 columns. Okay, what's our smallest foot length?
19. Oh, wait. Yeah. That's right.
Okay, check again.
Maybe?
Is it really?
Yeah. Yeah.
Yeah. Okay.
What's the key say?
Okay. All right. All right. So we are going to start going from 16 to 19. So if the bin width is like 4, we're going to skip count by 4s, right? We're going to say 16. Oh my gosh, I keep wanting to write B. Okay, 16 goes in that bin, 17, 18, 19, right? Okay, so 16 through the 19s are going to go in this bin. Okay, and then adding 4 will get us to, right. Wait a minute. Try again. Yeah, 20 to 23. Okay, and then the next one will be 24 through 27, and then 28 through 31, 32 through 35, and so we end at 36. Is 36 the biggest? Is there a 36? No? Okay. Okay, so these are our intervals. Okay, we've got, we can make a section for our tallies. And then over on the far right of our little special T chart is going to be our frequency. Oops, that's a G. I meant to put a Q. Okay. So I'm just going to go across my data and sort it. So my 28, I'm going to put in the 28 to 31 bin. And I'm not going to use pink because I already used a lot of pink and it's kind of overload. Okay, so 28 is going to go in this bin. Everybody okay with that? Okay, the 29 is going to go in the next bin. Just kidding, same bin. The 27s, there's 2 27s, boom, boom. They're going to go in the 24 to 27 bin. 29 goes in the 28 to 31 bin. 24 in the 24 to 27. Okay, now I'm going to be quiet and let you guys sort your data because I think you can probably get it. Okay, I'm going to let you guys do it too if you're watching this video so that this doesn't take forever. If I got it right. So I only had 1 in the 16-19 category. Okay, so I'm just going to put 1 for that frequency. I'm going to put my frequency as orange. 1. Okay. I had 6 in the 20 to 23. Did you guys get 6?
Yeah.
Okay. And then I had 22. Did you guys get, what did you get? You got 23? Okay, I'm going to write 22 for now. We're going to put a question mark by it. And then they're telling us it's 40, so if mine doesn't add up to 40, we know I'm wrong, okay? Smart math, right? Okay. 6 for the next bin and 4 for the last bin. Oh, that doesn't look right. Okay, I'm missing. Is it 23? Yeah. Is it supposed to be 23? Okay, yeah. I missed one. All right, whoever said 23 was right. Let's just pretend like I got that right. Yay, I did it. I'm so good at math. Okay. All right, you guys ready? Okay. What do you think I'm about to show you? All right, so from 16 to 19, or like, okay, from 16 to 20 is like one bin, right? But the 20 goes in on this side, and the 19.9 will go to that side. Is everybody okay with that? Some of you don't know what I'm talking about. Okay, where's 16? Here. Okay, there's 16. And it goes to 20. But anything that like is 19.9, 19.8 would go to the left of 20. And 20 goes in this bin. Okay, so I only had one in the 16 to 19 bin. So what is this? 2, 4, 6, 8, right? So that's a really short little squatty bin. Here's that bin. Okay, I didn't even go all the way up to 2 because I only had one in that bin. Did I not put 6, 12, 10, 12, 14, 16? I did go to 20, 16 to 20. Okay. Where is 19? Okay. If we had, okay. I was trying to simplify this, but I think we just need to write it all out because we're doing it. We're just doing it. We're going to do all of it. Okay. So you're not crazy. All right. So this is for X. Oh, shoot. Oh, shoot. Oh, shoot. All right. One more time. I'm going to try it again. Erasing. Okay. You ready?
Yeah.
Okay. So this interval is for x's that are greater than or equal to 16, but less than 20. Look at the symbols. So if it's equal to 16, it's going in this bin. Okay? But if it's equal to 20, is it going to go in that bin?
No.
It's going to go in the next bin. Okay? I was trying to like simplify it a little bit the other way, but I had, well, someone had a big brain today and was like not going to be satisfied with the simplified version. So we're going to do the big brain way. All right, so this one is going to be 20 is less than or equal to x is less than what? No, we got to go all the way up to less than 24. Right? Because this was the 20 to 23 bin, right? Isn't 23 less than 24? Okay, so I'm trying to say the same thing. I'm just saying it more exact and better right now. Okay, the next bin would be 24 is less than or equal to x is less than 28. I should have just done that to start with. I'm sorry. Okay, next bin. 28 is less than or equal to X is less than 32. Okay, last bin. 32 is less than or equal to X is less than 36. Okay, so now I'm going to make my bins match my colors. So 16 is here. It goes to 20, but it does not include 20. It just comes up to 20. Is this better? Is this making sense now? Okay, still confused. Awesome. Okay. You weren't very convincing though. All right, so this one only goes up 1. I only had 1 in that bin. Okay, next in my red 20 to 24 bin, I have 6. You remember on our histogram when we said that it was aligned left? This is what we were doing with the or equal sign. So the 16 goes in this bin, like the 20 goes in this bin, so they're aligned to the left. Okay. All right, my next bin, 23. Holy crap. Okay. I think that's right here. Oh my goodness. Okay. Because it's really noisy, especially when I'm making a video. Would you like to hear a video that had like, okay, no one wants to hear that, right? Right. Okay. Next bin also has 6. My aqua bin. Okay, my next bin has 4. My purple bin. Okay, what do you notice about the shape of this graph other than I forgot to put a title? So this is what? Foot lengths? Okay, so I got in trouble with Mrs. Madsen for using Bell. In Algebra 1, we were telling you that you could interchange Bell, symmetric, and normal, and she took me over the coals for that very gently. She was very polite, but she's like, don't tell them anymore. Because apparently there are some very specific criteria that we have to meet in order to be considered normal. Okay, so just because it has like a symmetric shape like a hill doesn't mean that it's actually going to meet the criteria of normal. I mean, it's likely to, but it doesn't mean for sure. So what we're going to say is symmetric, and then in AP Stats, you'll learn how to find out if it's normal or not. So you can say symmetric, possibly normal. We don't know yet. Okay. Okay, so you are correct. This is a symmetric, roughly symmetric distribution. It's not perfect, right? It's a little bit more in this bin than on that side. So we can say roughly symmetric. I would always get mad at my teachers if they taught me something that ended up being wrong later. So I thought I would just come clean about that one. I try not to do that to you guys, but apparently I blew it. All right, now we have to create a box plot for the data. So we need to find our 5-number summary. All right, so go ahead and enter that on your calculator. I am also going to enter it on my calculator on my big board. My big board. Okay, so everybody should be doing this because by now you've all seen that I definitely make mistakes and can't be trusted. So, the closer I get to this board, the dumber I get. All right. Go ahead and start putting this in a list. Okay, you probably don't need to watch me enter all of these. You get the idea. Well, I can tell by the fact that I'm on line 41 of my list that I have the right number of values, but who's to know if they're actually the correct values? I just cross my fingers and we'll hope. So hopefully I get what Coach Vogler got. All right. So I'm going to go to my stat. I'm going to go to calculate. I'm going to my one variable stats. Oh, good. I think I got what she got. What Coach Vogler got. It's either we're both right or we're both wrong. I think we're both right, so we're going to go for it. All right. So go ahead and use your 5-number summary from the calculator to make your box plot. Okay, so my min is at 19. Okay, remember that I'm asking you to label it as not only the min, but also with the 19. So I don't have to guess to see if you got it right. Next, our quartile 1 was at 24. Okay, our median, it looks to me like 2s. Our median was at 26. Does that sound right? Quartile 3 was at 27.5. Oh my gosh. Anyone running out of room? Okay, my max is at 35, so that's between 34 and 36. Next year, I'm putting in like a zoomed in number line because this number line is garbage. Garbage! Okay, make sure you've got your stuff labeled. Okay, so if we were looking at the histogram, could we tell exactly what the range is on the histogram? No, all we could do is offer an estimate for the range. Does everybody see what I'm talking about? Like, we would have to guess that the highest value was 36 and that the lowest was 16, and we would have to guess that the range was what, 20? Is that what the range actually is? Okay, so that's one thing that we can notice when we compare our box plot and our histogram is that we only were able to get an estimate for the range for the histogram. On part D. What else do you notice? Were we right about it being roughly symmetric? Okay. Okay, so let's look at the interval that corresponds to like going from quartile 1 to quartile 3. So the interval from 24 to 27.5. Okay, does everybody see what I'm talking about? Okay, look. So I lined these up on my word processor when I made this. So this is the only part about this that doesn't suck is that I like lined it up like a crazy person in the middle of the night. Okay, look at the 27.5, which is almost 28. What do you notice about that?
It lines up.
Yeah, so look at where like half of our data is falling between those two quartiles. Do you guys see that? I know. Okay, I get my pat on the back. Okay, and I get a cookie. Who's got my cookie? Nobody? Okay, you got to come prepared to class, guys. Okay. So the region, the interval between quartile 1 and quartile 2, that interval, it like half of our data falls in there about, right? I mean, it like 28 and then 27.5, but like so close. Okay, write that in your own words. About half of our data falls where? Between Q1 and Q3. Remember, we can't be on or at in a quartile, but we can be at or between quartiles, right? Half of our data falls between quartile 1 and 3, and that corresponds to our tallest bin on the histogram. All right, next we have to calculate the mean and the median of the data. Okay, we already have the median. It was in our 5-number summary. So what was the median from our 5-number summary? 26? Whoops. I'm in the wrong spot. Okay, so the median is 26. What about the mean?
26.05.
Okay, 26.05. Now, when I made this, I did not realize how close those were. So what I'm going to have you do is draw vertical lines just for the median. And for this one, you don't have to do the mean. Okay, just do the median, a vertical line, make it nice and straight. I'm going to use my little ruler guy.
I kind of did that. It doesn't line up. Hey.
26 is right here, right?
Oh, I took the block.
We're going to have to do it on both.
Oh, okay.
I mean, we could just use like the same vertical line. That's kind of fun. Boom. Look at me being efficient. Okay, and it says label it. So this is my median. All right, flip it. Okay, suppose that 6 students with the smallest feet were no longer included in the data set. Okay, we're going to replace them with students with the largest feet. Okay, we're going to remove the 6 smallest foot lengths from the data set and replace them with 37, 38, 39, 40, and 40. All right, so we have to find the little baby feet. So 19 is out. 20 is out. There's another 20. I see a 22. I also see a 23. There's another 22.
Yeah, bottom row. Right.
Oh, yeah. Okay. So how many 6? I'm at 5. So one of the 23, a 23 goes?
Yeah.
Okay. So those 6. All right, and we're replacing them with 37, 38, 38, 39, 40, and 40. Okay, so same bin size. Okay, set up your frequency table with your inequality intervals and go. I want everybody to do their own, but you may work together. Okay, shh. Okay, let's all pretend we're civilized for the video. Okay, so go to number 3 on the back. We just need to talk about some generalizations really quick. And then you can finish this on your own. Okay? You may work with a buddy. Okay? You will be able to check your work in Google Classroom once I post Ms. Vogler's key. But I want you to make sure that you have it done. Okay? Okay. So imagine that a histogram had so many bins that the tops of the bars appeared to form a curve. So like if you can imagine infinitely many bins where they just sort of like make a curve. In these 3 hypothetical data displays, one is symmetric and 2 are skewed. So we have to find the mean, median, and mode for each. Okay, and I'm going to tell you this little secret. The mode, guys, is always at the very tippy top because it's the most repeated, right? So do you see how this right here is the most repeated?
Yeah.
Okay, that one's the mode. Yeah. Okay, and then here again we have the mode. Okay, and then tippy top, mode. Okay, now of the 3 measures of central tendency, mean, median, and mode, which one is most affected by a tail? Correct, because if you have a really bad quiz score, and most of your quiz scores are good, doesn't your quiz average drop kind of a lot? Okay, but does your median score drop really? It may or may not, right? So whatever is the farthest from the mode on the skew is the mean, because that gets pulled in the direction of the tail. If you had me for algebra, you probably saw me like pulling like this, like a crazy person. Okay, so those are the means. They are the farthest from the mode. In a symmetric distribution, it's also hanging out with the mode in the middle, which means that the median may or may not be affected by a tail. So it's this one that's in between the median and the mode. This is the median. This is the median. And on the symmetric display, it is in the middle. Okay, while you are packing up, I need you to listen. I want to show you how to do one of these sentences. You guys ready? Okay, so you're going to have to do this. So I need you to listen while you pack up quietly. For skewed data displays, the median is often a better estimate of the center of the distribution than the mean because... So, oh my gosh. Are you kidding me? Because we have to explain why, right? So the median is often a better estimate of the center of the distribution than the mean because why? What is the mean affected by? A tail, because the mean is really affected by extreme values in the tail.